everybody, welcome back to Calculus. Today we're going to do a review of the implicit differentiation that you were working on before break. This way you can have stronger skills in implicit differentiation. You can remember how to do implicit differentiation because we are going to need it this chapter. So let's get started. All right, so here's our goals for today's lesson. First, we want to review implicit differentiation, clarify what that is. We're going to practice applying the power, product, quotient, and chain rules in implicit differentiation problems. The reason we're doing this is because this chapter that we're working on relies heavily on your skills with implicit differentiation. It's like the second or third step in every problem we're going to do. So you need to have strong skills with implicit differentiation. So let's get to it. All right, so there's 3 levels of implicit differentiation problems we're going to work on today. Here's level 1. So just a reminder, implicit differentiation, that's when you're taking the derivative of an equation that has an x and a y in it, and you're not bothering to get the y by itself first. So what you'll do on these is first, you'll just take the derivative. You'll remember to use dx and dy dx appropriately, and I'll talk about that in just a minute. Then after you take the derivative, remembering to use those, you're going to solve for dy dx. And once you get really good at this, you can also kind of skip the whole dx part, because remember dx divided by dx is 1, and anything times 1 is that thing. So here we go. Let's work on this. When I go take the derivative, first of all, I want to look and make sure that there are no quotients, products, or places where I could apply the chain rule. I'm not seeing any of those. I'm just seeing a string of terms, so I can just apply the power rule for each one of these. The derivative of -5 is 0. Derivative of 3y cubed is 9y squared, but I took the derivative of y, so I need to write dy with respect to x equals. The derivative of 5y squared is 10y dy dx. Take the derivative of y with respect to x. Plus the derivative of 3y is 3 dy dx. Plus derivative of x squared is 2x dx dx. Just remember, though, that dx divided by dx is really 1, because anything divided by itself is 1. And so if you don't want to write the dx, you don't have to anymore. But you do have to write dy dx because that is not 1. All right, so we've taken the derivative. Now I want to solve for dy dx, which means I need to look at all the places where there is a dy dx. And I want to isolate those. So I'm thinking I'm going to move all my dy dx's over to the right side. So I'll subtract 9y squared dy dx. So right now I have 0 equals 10y dy dx plus 3 dy dx minus 9y squared dy dx plus 2x. Now I want to get all the dy dx's on one side and the terms that do not have dy dx on the other side, so I'm going to subtract the 2x on both sides. So what that's going to look like is just having a negative 2x on this side. To get the dy dx by itself, you can factor out the dy dx from the right side. So that I'll be left with 10y plus 3 minus 9y squared is equal to negative 2x. And then to solve for dy dx, I'll divide everything by 10y plus 3 minus 9y squared. So negative 2x divided by 10y plus 3 minus 9y squared equals dy dx. So there is my answer. That's the derivative, dy dx. Remember doing that? Okay, remember these also get, well, I think we did level 1 before, so they do get a little more complex. So here's level 2. They get more complex because you have to also apply the product rule, quotient rule, and the chain rule sometimes. Just depends on what you have. So if I look at this example, I am looking at all the terms, and I notice that right here, this negative xy is a product. So that tells me right here, I'm going to have a product rule. Now remember, the product rule is first derivative of second plus the second derivative of first. Anything else? No other product rules because I don't see an x and a y multiplied by each other. Okay, so let's work on this negative x times y. Product rule would be first, so negative x times the derivative of y, which is 1 dy dx, plus the second term, which would be y, times the derivative of the first, negative 1 dx dx, but dx dx is 1. So I don't really need the dx dx. All right, so that's my product rule part. First derivative of the second plus the second derivative of the first. Now I'll continue with the derivative of the rest of the problem. So plus the derivative of 5 is 0, minus derivative of 5y squared is 10y dy dx, equals derivative of 3y cubed would be 27x squared dx dx. But again, dx dx is 1, so I don't need the dx dx anymore. Once you understand what the dx dx is and that it ends up being 1, you don't really have to write it anymore. We just did it so that you'd understand why we have to write dy dx and why we don't have to write dx dx. All right, so let me simplify this. I get negative x dy dx minus y minus 10y dy dx equals 27x squared. Then I'm looking for the dy dx terms. So I need to add y to both sides to isolate the dy dx. So negative x dy dx minus 10y dy dx equals 27x squared plus y. Then if I factor out the dy dx, I'll have negative x minus 10y equals the 27x squared plus y. Solving for dy dx, I'll have 27x squared plus y divided by negative x minus 10y. And there's dy dx. Level 2. Just had a product rule in there we had to handle. So let's bump it up to level 3 now. Oh, gotta delete this ink. Level 3. Ooh, here we have a radical. Remember that whenever you have a radical, that's the same, or a square root, as having what's underneath that instead of the square root of it. You can have x plus 3y squared raised to the 1/2 instead, equals 4x. So now that I have a parentheses to a power, this is a place where we apply the chain rule. And I'll apply the chain rule because I have an outside function of the parentheses to the 1/2. And then the inside function of x plus 3y squared. Just trying to color code a little bit here. And then don't forget, if you take the derivative of y, you need to write dy dx. All right, so let's take the derivative of the left side. Derivative of the outside function will be 1/2 with the parentheses. Subtract 1 from 1/2, we get negative 1/2. And then just carry down what's inside the parentheses. Times the derivative of the inside part. Derivative of x would be 1. Derivative of 3y squared would be 6y dy dx. And then equals derivative of 4x is 4. Okay, so it's kind of hard to see because there's some parentheses, and do I need to distribute or not? So I'm going to turn this back into a radical expression. 1 over 2 square root of x plus 3y squared times the 1 plus 6y dy dx. Then bring down the equals 4. Okay, now when I am, let's see, if I want to try to get the dy dx all by itself, this is what I'm trying to isolate. I need to get rid of the 2 square root of x plus 3y squared. So I'm going to multiply both sides of the equation by 2 square root of x plus 3y squared. Multiply it on the left, multiply it on the right. So what that is going to give me, let's see, on the left side that cancels out, and 1 times what's in the red is 1 plus 6y dy dx equals 4 times 2 is 8, so 8 square root of x plus 3y squared. Okay, then I'm trying to get the dy dx by itself, so I can subtract the 1 on the both sides. Let's see, I need more space, so I'll come up here. Now I have 6y dy dx equals 8 square root of x plus 3y squared, then minus 1. Notice the minus 1 is outside the square root. And then to isolate the dy dx, you can divide both sides by 6y. So I have my derivative dy dx equals 8 square root of x plus 3y squared minus 1 all over 6y. We'll do 3 examples of the level 3 because they do all include the chain rule. So here's another one. This time we have a cosine function of the chain of implicit differentiation. Here, my outside function would be the cosine part. And then the inside function would be the xy squared. But notice with the xy squared, we have a product. So we'll also have to apply the product rule there. And then equals y. Okay, so here we go. Derivative of cosine is negative sine of the thing, and we just carry over the thing, times, now I need to apply the product rule for what's in here. So first, derivative of y squared would be 2y dy dx plus the second y squared. Derivative of the first is 1. First derivative of the second plus the second derivative of x, which is 1. Have my dy dx because I took a derivative of a y. Equals derivative of y is 1, but I took a derivative of y, so I need dy dx. Okay, so let's see. Can we clean this up a little bit? Oh, I solved it. Here it is. dy dx is, oh no, it's not. There's another dy dx in here. Okay, so let's clean this up a little bit. Negative sine of xy squared times 2xy dy dx plus y squared equals dy dx. So I'm going to highlight this is a term and this is a term. I need them all to be on the same side. The thing to think about though is that this sign needs to be multiplied to both parts. So maybe I'll distribute that sign to both. So I'll have, let's see, negative sine of xy squared 2xy dy dx minus the sine of xy squared times y squared. So I'm going to put that y squared in the front so it doesn't look like it needs to be inside the parentheses, equals dy dx. Then I spot this dy dx, I spot this dy dx. I'm going to move them to both sides. So I'm going to add sine, this big long sine. I'm going to add that to both sides. So I have negative y squared sine of xy squared equals dy dx plus sine of xy squared 2xy dy dx. Again, I need more room. So I'll factor out the dy dx from each of those terms. Let me bring over the left side first. Negative y squared sine of xy squared equals, factor out the dy dx, times sine of xy squared 2xy Oh, and I forgot to factor it out from here. And when you factor out dy dx from dy dx, you just get plus 1. So then when I divide this by this by sine of xy squared 2xy plus 1, I end up with negative y squared sine of xy squared over that other part, sine of xy squared 2xy plus 1, that's equal to my derivative, dy dx. We are flexing our calculus today. We should show this off. You all should work these out and put them on your refrigerator because look at all that calculus. All right, we've got one more of these to look at. All right, here we go. Last one. And this one, you'll be pleased to see that there's not as many differentiation rules going on. I do have a, let's see, what is this? I have parentheses to a 5, so this looks like I'll have a chain rule with the outside function being the parentheses raised to the 5th power, the inside function x cubed plus 2y squared. So I've got an outside function and inside function, but it's not mixed with a product or quotient rule. So here we go. All right, so 5 parentheses and then subtract 1 to the 4th, and then again just copy down what's inside the parentheses. Now I need to take the derivative of what is inside the parentheses, and that's going to get multiplied by all that other stuff. Okay, so derivative of 3x cubed is 3x squared dx dx, but I don't have to write the dx dx because that's 1, plus derivative of 2y squared is 4y dy dx equals derivative of y is 1 dy dx. Okay, so now I'm looking and I see that I have a dy dx here, dy dx there. So now I need to look at how do I get the dy dx's on the same side. So I've got this dy dx and this dy dx. I need to get them on the same side. I can't really multiply what's in the red to this term because what's in the red would need to be raised to the 4th power first. Then that 5 would need to be distributed. And no one here wants to multiply something out 4 times and then distribute it 5 and then distribute it. So there is a shorter way to do this. So what I can do is I can take this entire expression, this entire part in the red, and I'm going to distribute it to the 3x squared, and then I'm going to distribute it to the 4y dy dx. And that's how we'll handle that. That will help us get the dy dx's closer together. So when I first distribute the 5 parentheses x cubed plus 2y squared to the 4th times 3x squared, the 3x squared times 5 would be 15x squared times x cubed plus 2y squared to the 4th. So that came from multiplying this part times 3x squared. Now I'm going to distribute this to the 4y dy dx. So 5 times 4y is 20y times what's in the parentheses, x cubed plus 2y squared to the 4th power dy dx equals dy dx. So now I can start to see, okay, well, I've got a dy dx here. Whoops. I need my green pen. Where's my green pen? Have a dy dx term here. Have a dy dx term here. I need them on the same side. So I'm going to subtract the dy dx and I'm going to subtract the 15. So that my equation now looks like 20y x cubed plus 2y squared to the 4th dy dx minus dy dx equals that part in the red, the 15x squared times x cubed plus 2y squared to the 4th. So then on the left, that's where you can start to factor out the dy dx. 20y times x cubed plus 2y squared to the 4th minus 1, because when you factor out the dy right here, that second dy dx equals the 15x squared times x cubed plus 2y squared to the 4th power. So now all I have to do is divide. I just need more space to do that, so I'm going to come up here. Dy dx equals 15x squared times x cubed plus 2y squared, all that to the 4th power, all over 20y times x cubed plus 2y squared to the 4th, and then minus 1. All that needs to be in the denominator. And oh, you know what I did forget though? This 15, when I moved it to the right side, it should have been a negative 15. So just make sure that 15 is negative. And that should be it for today.